Boom! Yes, folks, Hume again. How are you going? So in this video, we come to the second in my particular order of giving the circle theorems. Alright, just remember that the order in which I give them will not necessarily be the same as the order in which you will see it in textbook A, and then textbook B might have a slightly different order, and then your teacher in school might have a slightly different order, and then your neighbor across the road who helping you with maths might have a slightly different order. The order is not important, right? I choose a particular order based on how I am discussing this thing. The order is not important. What is important is that you learn all the theorems. Alright? So this is the second. This is my second. My second might be somebody else's. Third, it might be somebody else's. First, who knows? Irrelevant. So we proceed. The theorem reads as follows. The angle subtended by a chord at the center of the circle in one segment is twice the angle subtended by the same chord at any point on the circumference in the alternate segment. Let me read that again. The angle subtended by a chord at the center of the circle in one segment is twice the angle subtended by the same chord at any point on the circumference in the alternate segment. It sounds like a lot to digest, alright? But like anything else in life, it looks a little intimidating at first, and then you break it up, alright? As I tell my students all the time, there is only one way to eat an elephant. That is one bite at a time. You can't swallow an elephant, alright? So we proceed. This is what we would use to explain this particular theorem. Particularly these two circles, we will deal with this one a little bit. So let us go through it. The angle subtended by a chord at the center of the circle in one segment. So we pause. The angle subtended by the chord AB in, hold on. Yeah. Remember, we discussed in the very first video, we discussed the major segment and the minor segment. So remember that any chord of the circle will inevitably divide the circle into two segments. Once that chord is not a diameter, you would have a major segment and a minor segment. It just means that one segment will be bigger than the other. Of course, the bigger one will be the major one, and the smaller one will be the minor one. So in this case, you have this chord AB. This is the same chord AB, identical chord. But you notice we have different angles denoted in the circles, right? Same circle, same chord, same center, but different angles subtended at the same center. So in this circle, we have the chord subtending this angle at the center, but this angle is subtended in this segment. So let me see. Excuse. So this here would be, this is the segment, alright? This is the segment that we're talking about. This chord, the chord in this segment subtends this angle at the center, alright? Now this in black is the minor segment. So in this circle, the chord subtends this angle at the center in the minor segment, as opposed to this circle here, where the same chord subtends the angle, watch it now, subtends that particular angle in red in the major segment. So same chord, different segment. Alright, let me try and keep the black on the line now. Alright? You're doing anything in real time here. Real time business. Let me see. Hold on. Yeah. Whew, yeah, boy. Better concentrate here, you know. Ay, ay, ay. Yeah, the line a little wobbling a little bit, but I'll look at the point, alright? if I was in a live class, we done draw some crazy looking thing already, you know. But we're trying to make it nice now. Alright, since we tape any video and thing. Alright. That's good enough. We can take that. So in this circle, we have the chord AB subtending this angle in the minor segment. And here, let me read the theory again. The angle subtended by a chord at the center of the circle in one segment. Remember, there will only be two segments. Alright? So in this case, we subtending the angle at the center in the minor segment. It means, therefore, that will be twice the angle subtended by the same chord, at any point on the circumference of the alternate segment. Circumference in the alternate segment. The alternate segment, of course, will be this section here. So any angle subtended at any point here will be half of this angle here. So in this case, the chord subtends a particular angle at the center in the minor segment. That angle will be twice the angle subtended by the same chord at the circumference in the major segment. On the other hand, we have the same chord AB in this situation, same exact chord, right? In this instance, however, the chord subtends this whole angle here at the same center, but in the major segment. Alright? So the chord, that's the major sector or the major segment? That's the major sector. Okay, segment. Let me leave it as segment because the chord defines the whole segment anyway. Alright? So the chord AB subtends this angle in the major segment. So if the chord subtends the angle at the center in the major segment, it means therefore that this angle would be twice the angle subtended by the same chord in the minor segment. Alright, so let me read it again, just to repeat. The angle, the angle subtended by a chord at the center of the circle in one segment is twice the angle subtended by the same chord at any point on the circumference in the alternate segment. Good. So the definition reads like a whole paragraph, but you could break it down. And then once you break it down and understand it, what you find is that students invariably find some kind of shorthand way of writing this. Because let us face it, in our exam, there are so many ways to write this that most examiners wouldn't penalize you if you don't write it out exactly like this. Alright, once you get the main points across, they get what you're saying and they get your marks. So don't get so caught up on memorizing the whole theorem that you neglect the most important part, which is to understand it, which is to remember it. Once you understand it and want to remember it, then you more or less have a almost free hand to develop your own vocabulary to describe the theorem. Alright? So let me explain it again. Yes, repetition is part of the thing. The angle subtended by a chord at the center of the circle in one segment. That's the important part. Because the same chord could subtend up to two angles at the center. The same chord AB could subtend an angle in the minor segment in black here. It could also subtend an angle in the major segment. At the center, subtend an angle at the center, minor segment, subtend an angle at the center, major segment. Once we establish which segment we're speaking about, then that's the main thing. Right? This, of course, is much easier to see visually, especially when you have a diagram with a whole lot of circles, a whole lot of lines and triangles and tangents and radii and stuff. Alright, and that is where the practice comes in. The practice comes in being able to see through the haze and understand what's going on. But that is something that you could only develop by practice. Even after you watch my videos and you realize that you understand anything. Alright, so the same chord AB subtends at the center of the circle in the minor segment, this angle here. Which means that this angle is twice whatever angle that it would subtend at the circumference in the major segment. Alright, and as we would have seen before, it doesn't matter where on the circumference this angle is. Once it is subtended by the same chord, it will be the same. So it could be subtended here, or here, or here, or here. All of the different angles will be the same. So once we get the angle subtended at the center in one segment, then that angle is twice the angle subtended by the same chord anywhere along the circumference in the other segment. In this case, we subtended at the center in the minor segment, which means that that will be twice the angle subtended at the circumference in the major segment. On the flip side here, same chord AB, subtending an angle at the center of the circle in the major segment. So in this case, the angle subtended at the center is in the major segment, which means that this angle would be twice any angle subtended along the circumference in this minor segment here by the same chord. Alright? So that's basically it, you know. That is basically it. Alright? So that is the second theorem. Now, this leads straight to the third theorem. So basically we're covering two theorems in this video here. Right? Remember, we would have discussed in the very first video, that the diameter is a special chord. The diameter is simply a chord that passes through the center of the circle. So therefore, when we take this chord and we carry it up to the center, which is what we have here now. So let us say, for the sake of visual completeness, visual consistency, let me take the orange and make it into a green now, right? Just to drive the point home. You see, you had to take care of these little details, eh? Yeah, you had to take care of these little details when you're doing the thing. Alright? Alright. Yeah, it's kind of greenish. It's not full green, but we get the point. Alright? So, this chord AB obviously is not the same as this chord. This chord is the same as this chord, which we then take and we move it up till it runs through the center of the circle. So it has now been elevated to the status of a diameter. So this chord, which also happens to be a diameter, subtends this angle here at the center of the circle. That angle we know is 180 degrees because the angle at any point is 180 degrees. So if this chord, which is a diameter, subtends an angle of 180 degrees at the center of the circle in this segment, alright, and again, for the sake of visual consistency, let us denote the segment as follows. Alright, this is the segment in which is subtending at the center. Alright, hold on, just bear with me, alright? We will get it done, don't worry. Alright, so we subtended. And the same way we had the two radii denoted here, we do the same thing here. So we now move from orange to green to black. Alright? So the same two radii, right? So in other words, just as we discussed in the very first video, we have a situation now where instead of having a chord, the chord move up to a diameter. And by virtue of being the diameter, we now have two radii, which subtends the angle at the center. So everything kind of merging. And that's another principle in life too. Speaking specifically to the younger ones now, you'll find a lot of merging taking place all over. In all kind of different spheres, things just seem to be crisscrossing. That's part of life. But a lot of times it's not just a straight line. Alright? So we have the chord AB, which subtends the angle at the center in this segment. And the theorem is saying that that angle is twice the angle subtended by the same chord on the circumference of the alternate segment. So in other words, any angle subtended by this diameter in this segment, anywhere in this segment, will be equal to 90 degrees. And that is why the very next theorem, the third theorem on my list in terms of how I'm doing it, is the one that says, and I quote, hold on, quoting from the syllabus with some minor modifications, the angle subtended by a diameter at any point on the circumference is a right angle. Because if this angle is 180 and it is twice this, then this will naturally be half of that, which is 90 degrees. Alright? And that is why for any diameter, because the diameter by definition would subtend 180 degrees in one segment, which based on this theorem here, the second theorem on my list, means that the angle subtended by the diameter in the alternate segment must be 90 degrees. So by virtue of this, we know that the angle subtended by any diameter at any point on the circumference is a right angle. And that's basically it. So the way in which the thing evolved, I couldn't really separate this from this and this. Alright, so I just put everything in one. And hopefully, the idea here is that by doing it in this particular order, it allows you to understand the thing better, right? Circle theorem is one of those things where it's kind of tricky to teach, right? It is not everybody who would just read it in a textbook and understand it. It is not everybody who would look at a YouTube video and understand it. You might not even understand it when you look at my video. So I'm not here trying to behave as if the only place you'll understand it is on my video. No. Right? I just doing it how I think is the best way to do it in terms of getting people to understand it. We talk about it, we demonstrate it, we read it out in some nice vocabulary. Alright, and of course, the follow-up to that would always be to do your questions. Right? Whether you do it with me, or with the teacher in school, or with somebody else, really that is beside the point here. Alright, so you get my theorem 2 and 3 in one video. Alright, so we progressing, we have a few more theorems to deal with. Alright, and I really hope and trust that you understand anything as we go along. And again, as always, I want to encourage you to stay in the game, come back for more, because we have plenty more coming up. Boom!